Alright, so through any two what? Through any how many points?
2.
Alright, so through any 2 points, there is exactly 1. Look at us go. If 2 planes intersect, their intersection is a 1. It's like we've learned something. Alright, a line contains at least 2 points. If 2 points line a plane, then the entire... I'm telling you. I'm so proud of y'all. Alright, number 5. Through any...
3.
There is exactly 1 plane. Alright. If 2 lines intersect, then their intersection is a... A plane contains at least
3.
non-collinear points. Alright, determine whether the following are always, sometimes, or never true. We're not going to explain because we don't have a lot of words. A lot of room. A lot of, what I'm trying to say. Humana. 3 points determine a plane.
True.
Always, sometimes, or never.
Always.
What if they're collinear? They have to be non-collinear. So sometimes. Alright? The intersection of 2 planes can be a point. Sometimes. There is exactly 1 plane that contains non-collinear points P, Q, and R.
Sometimes.
Why sometimes?
If
If there were 2 planes that contained all 3 points, wouldn't those planes be the same plane on top of each other?
Yes. They could intersect
And then contain all the points?
Yeah.
How?
Because P and Q could be on this plane and R could be on this plane.
But this says that there is exactly 1 plane that contains the points. So I would go with always.
Always. Wait, 3 is always?
Mm-hmm. There are at least 2. Yeah, you just said it, so that's another 5. There are at least 2 lines through points M and N. Never. If points A, B, and C line in plane M, then they are collinear.
Never.
Sometimes.
What?
It's not saying that those points make up the plane. It just says that they lie in the plane. So sometimes. Now, what we're doing today is we're doing algebraic proofs, which means we're going to be using our algebra that we learned last year. Crazy. So, the algebra property of equality, the addition property of equality just means that if A equals B, then A plus C equals B plus C. Yep. So you would use the addition property of equality when you have x minus 7 equals 3. And can anybody tell me why we would use the addition property of equality for that?
Because you add 7 to
Because you would add 7 to both sides. You would switch. Good. Both of you take a point. Good job. So what would an example of the subtraction property of equality be?
X plus 4 equals X plus 7 equals 3.
So everything y'all just said is correct as long as you have a plus. Good. Take a point. So the multiplication property of equality, what's the opposite of multiplication? Division. So if we had x divided by 2 equals 4, that would be the multiplication property of equality because you have to multiply to get x by itself. Does everybody see what we're doing?
Yes.
Does anybody not see? Okay. The division property of equality. Can somebody raise their hand and give me an example? Caitlin?
X times 2 equals 4.
Okay, so 2x equals 4. Awesome. Take a point. The reflexive property, symmetric property, and transitive property are what they are. So reflexive means it's the same thing on either side. Symmetric means you would fold it up and they would touch each other. The transitive means you move it around like a train. Substitution, you plug in. And we all know the distributive property, correct?
Yes.
Okay, so what we're going to do for the first part is we're going to state the property that justifies each statement. Are we ready?
Yes.
Let's look at number 1. What do you think that is? It is the symmetric property. Take a point, Tater Tot. Alright. Now, it's symmetric because if 5 equals y, then y equals 5. Symmetrically folded up, they touch each other. Alright, number 2. If the measure of angle A equals the measure of angle B, and the measure of angle B equals the measure of angle C, then the measure of angle A equals the measure of angle C. Transitive. Pardon? It's transitive. Now let's think about why it's transitive. These two in the middle move away, and those two on the outside come together and they make a family. Does everybody understand?
Yeah.
Alright, what about number 3? How did you get subtraction? You saw the addition sign and you subtracted to get 15? You just put what? Okay. What about number 4? Oh my God. Why did you just do that? It is reflexive. Thank you. Take a point. Screamed. Alright, what about number 5? Is it? I don't think so. Okay, let's talk about what it says. It says angle 1 plus angle 2 is 90, and then angle 2 is equal to 3, and then what did we do right here? You take a point. You substituted. Just right, substitution. That way you don't confuse it with subtraction. Now, the reason it's substitution is because we said that 2 equals 3, and then we plugged 3 in for 2. That's why we wrote plug in. Alright, what about number 6? What did they do?
Division.
So that is the... they divided, so what is that? No, it's the division, y'all. They divided, so it's the division. If they multiplied, it would be the multiplication. What about number 7? Transitive. That one is transitive. Because the 5's moved away and the X and B came together. Alright, what about 8? Yes. And what about 9? Addition. Take a point. Okay, so what we're going to do in our 2-column proofs today is I'm going to give you a problem, and then we are going to practice solving it and then write down what the property is that we used. Are you ready? Please be ready. So we're starting over here with number 1, where it says write a 2-column proof. So can you please draw 2 columns? You guys know what columns are?
Yeah.
That's okay. Let's just take a deep breath. So we're going to draw a line. And we're going to draw another line. And then at the top, we're going to write the word statement. And then over here, we're going to use our word reasoning. Now, in a proof, you have to justify what you're doing, and that's what we're learning how to do. We're justifying our reasoning. So this says that if 2 times x times the quantity of x minus 3 equals 8, then x equals 7. So what we're doing is we're proving that this is a true statement. Curtis, why is your phone glowing into your glasses? An angel did not fall on your desk. Thank you. So we are proving that this is a correct statement, and what we're going to do is we're going to solve it step by step and give our reasoning. Are you ready?
Yeah.
So number 1, every single time, just rewrite the problem. And the reason that we wrote that is because that was given to us. So start with your given statements. Now, can anybody tell me, when we are solving this, what would we do next? Caitlin? You would distribute. So you would distribute the 2 to the x and the 2 to the negative 3, and what would that become?
2x minus 6. 2x minus 6.
Good. And that is the distributive property. So over here, you're going to write distributive property. What would be our next step? Add 6. And what property is that?
Addition.
The addition property. So what would that give us? 2x equals what?
14.
Good. So then that's the addition property, and you can just write addition. And then what's our last step? Divide by 2. So that would be the division property, and x equals 7. Boom, we're done. Now, I want you to write out that it's addition. I want you to write out that it's a division and not just put the letter, because we have multiple letters that are the same thing. Yeah. This is an algebraic proof. Isn't it lovely? Why?
We did this last week.
Kind of. Yeah. No, write addition property. Because what if it was the applesauce property? You're not even listening. Number 2, are we ready?
Yes.
Are we sure?
Yes. I promise.
Now, what should I do first? Draw my 2 columns. So each time, draw your 2 columns. And then on the top left, what do we write? Statement. And on the top right, what do we write?
Reasoning. You can't have a statement without a reason.
Exactly. Bless you. Alright, so for number 1, what do I do?
Rewrite the problem.
Look at y'all go. So I have 7 halves minus n equals 4 minus 1/2 n. And then what do I write over here for my reasoning?
Given.
Given. Cameron, are you with me or are you playing with a stapler? Are you sure?
Yes.
Can you tell me what I do for step 2?
No.
Why? You know how to solve equations. You do know how to solve equations. Yes, you've been solving equations since like the 7th grade. So tell me how to solve this equation. What would I do next? Put your hand down. Say it to me again. Can't. 1, we don't say over. 2, you can't combine these because they're not like terms. And 3, we need to get this in over here with this one. So how would we do that? What? Baby, you got to be able to do this without me, because what if I die? It's a negative 1/2 n. How do we move this over here?
You take the 7. Can I just take 7 over?
No, pumpkin. Pumpkin, I want you to tell me how to move this negative 1/2 n over here.
Combine them.
Baby, it's a negative. What's the opposite of negative? Look at you go. Fantastic. So everybody, add 1/2 n to both sides. And what property is that?
Addition.
The addition property. So what are we going to write over here for step 2? Addition. You're not going to write that. You're going to write addition. What if it's the applesauce property of equality? Alright, so can anybody tell me what this equation turns into? What do I have? 7 halves. And what's negative 1 plus a half? Minus 1/2 n. Good, take a point. Equals what?
4.
Fantastic, because this cancels. Does everybody see where we got the negative 1/2 from?
Yes.
Because if you owe me $1 and you only pay me back half, you still owe me half. Does everybody understand? Okay, now what would I do next? Subtract what?
1/3.
No, what would I subtract?
7
7
halves.
halves.
7 halves. So that would be negative 1/2 n equals, can anybody tell me what 7 halves minus, 4 minus 7 halves is? You have calculators, don't you? Put it in parentheses. 1/2, is it a positive or negative 1/2? Fantastic. And what property was that we did that? Subtraction. It's not. Pardon? It is. Alright. Can anybody tell me what we do next? How do we get rid of that fraction?
Multiply.
We multiply to get rid of fractions. What would we multiply by? Flip the fraction. What would we multiply by? Positive or negative? Negative 2. That cancels. You have n equals, what's 1/2 times negative 2? Which one is it? 2 goes into negative 2 how many times? Negative 1. Negative 1 times 1 is negative 1. Dun 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 dun. We did do it. Alright, we're going to start number 3 together, and then you're going to finish it for homework. Are we ready?
No.
Why? Because we're never ready?
Yeah, Miss Azra. No, we're not gonna let you. What? Dang, man. Jesus.
That's fine.
That's why she keeps say all that.
Yep. Just next time he needs help, he cannot ask me. Alright, statement. Reasoning. Okay. Now this one, I'm not going to walk us through step by step. I want you to tell me how to do it. Now, what does it say? This says that if angle y is congruent to angle z, then x must equal 100. And it gives us the angles in algebraic form. So what should we start with? What's our given?
Angle Y.
Angle y is congruent to angle z. Yes. Kaylin, I see where you were going with that, but don't go there yet. So that's our given. Now, do we know what angle y is?
Yes.
What is it?
X plus 10.
So we would say that x plus 10 equals,
2x minus 90.
yes, 2x minus 90. And what property is that? What did we do from here to here? We substituted. Great. No. Substitution. Now, for homework, I want you to finish this one without me. Does everybody understand? Work it out. Tell me the reasoning. Then we're going to come back and practice some more tomorrow. Isn't it a lovely day?
No.
It's a great day to have a great day.